So today we'll be going over lesson 7.1 and specifically covering the Asynctask class in Android. I've got some slides today. I've got some example projects that I'm going to give you, actually 4 today, because this can be used to do a lot of different things. So one application doesn't really do a good job of showing what you can do with this. So you'll be getting a few of those, and should you want these slides, I'll have them posted on perusal later. Any questions going forward?
How does this compare to the node async await thing?
There is some commonality in the sense that they're both used for doing asynchronous work, but it's a very, very different approach. So objectives for today is we're going to talk about how you can move work off of the UI thread and onto background threads. That's the main reason that we're talking about this. The reason we want to do that is we want to keep our apps responsive while at the same time being able to perform long-running tasks or jobs, things that take a little bit longer to do. And namely, that cutoff is around 16 milliseconds is what you have before you need to push things to a background thread. That's about the cutoff. If you want to keep your application running at 60 frames per second, that's the absolutely upper speed limit of 16 milliseconds, which is pretty low. So that means there's a lot of things, even things that may seem very quick to us, still need to be pushed to a background thread. Because either there is some variability, they can take longer, or they just always take longer. So it may be that there are definitely things where it's like, well, it works on my machine and it works under 16 milliseconds. That may be okay for you in your emulator, but it might not take that long. Say you're trying to go contact a website and you're out in the sticks somewhere, you're out in the country. It may take longer for the network time to go get that resource, even if it's a relatively small resource. So, working into and working towards, accessing network resources over HTTP, REST APIs, etc., we need to understand how to work with communication between the UI thread and background threads. So that's one of the things that we're going to be talking about today, is using async to do that communication between the UI thread and background threads, or just even spin up background threads, because everything we've done so far has just been on the UI thread. Now, a few warnings. There is a lot of information online about this Asynctask class. So take everything that you find online with a major grain of salt, because there is just so much misinformation embedded into the examples that you'll find, whether it be Stack Overflow or other places. People really do not understand how to do this right. And part of that comes to there are 5 or 10 different ways to do the same thing. And the async task is relatively small, but there's a lot of things where you can make a mistake, because there's a lot of things going on under the surface and things going around, things that you have to watch out for, that even though it is a small class and it may seem very easy to understand, it's often only a few steps away from being a total disaster. If you just miss a few things or misunderstand how things need to work. So be very careful about that. Also warning, as I've kind of said, a lot of tutorials provide bad guidance. So be very careful about different tutorials that you look up online, different examples. Those code examples may not be correct. And even Google's own documentation is a really poor guide of how to do this right. If you read, there's some great information in your chapter for 7.1, but there's also some information that is actually incorrect, and is not really how you want to approach things. So just be forewarned, be careful as you're learning about this. to pay attention to do it the correct ways, and watch what some of the caveats are, because if you don't get this right, well, it can lead to your application crashing, running out of memory, all sorts of bad things if you don't follow the right steps.
Is there like a system or something we should be on the lookout for when searching for information about this? Because like if we're watching a video and we do it, and like after a certain point we don't know whether or not it was the tutorial or what's going on.
So one of the things I will say, we'll get into some of the things as I walk through, but there's a few things to watch for. I'm going to show you how to do this using nested classes, which I have found is 90% of the time the right answer, is to use a nested class in Java. Only maybe 1 to 5% of tutorials will use a nested class. And that's usually the first place that they go wrong. The second thing that they don't do is they don't clean up their tasks. So they'll start a task and not cancel it or stop it when the activity is destroyed.
Sorry to interrupt. Is that called garbage collection?
No, garbage collection is something else. In fact, actually, that's the problem, is people assume that garbage collection will do the job for you. Tasks are something you have to clean up yourself. You can't rely on garbage collection to clean that up for you. Because if you do, your application will crash, which a lot of people make that mistake. They assume that garbage collection will automatically take care of their task. It will not. Okay, so there is code that you have to write in order to make that work, and there are definitely a lot of gotchas with that to making sure you clean up after yourself. And so be forewarned with that. So nested classes is one thing. A third thing in there is actually how you kick up and start the task in the first place. That's the other side where people make mistakes, and honestly, the part of the reason there is that you shouldn't do what Google tells you to do when you're starting a task. So they tell you to put in the data one way. You actually should put it in a different way. So it's on starting the tasks, on stopping the task, and also what file do you even put these classes in. Those are the kind of areas where I've seen the most kind of misunderstanding of all of that. Okay, does that help, Corey? Answer your question?
Yeah.
Okay. So kind of some background on this. Understanding the async tasks is something that's really important, especially for all of the upcoming lessons. For the rest of this 40 days, async tasks are of vital importance, and understanding background threads and all that, because everything that we do with files or databases or the internet, all of that needs to be done on background threads. So, that's basically what we've got left in this semester is, except for a few, I think maybe two lessons or so, what we do will be around files, databases, and the internet. And so those things all need to be offloaded to async tasks. What that's going to mean, for instance, is that you will likely, as things grow, you may find yourself creating a lot of asynchronous tasks. It's very likely that you will need at least one per activity, if not more. Okay. So this is an important topic to have some understanding with. Now, we will cover some technologies in the coming weeks that will make this easier and may mean that you potentially need to write less asynchronous task subclasses. But it's really, you're still going to find yourself writing at least a handful. There's not really a way around that. Plus, it's very hard to make asynchronous tasks that are generalized, where they can do a boatload of different things. They tend to need to be very, very specialized to one specific thing, like getting a single product from the database, or getting a list of products from the database, or performing a search. All of those things may require a specific task implementation to do. I will say that as I was learning this Android, several years back, I did find this a very difficult topic to find good documentation about. And part of that is that, just all the misinformation that exists out there. So there's a lot of things I've learned over the years, and the way that I have tried things and iterated has really changed. So that's where my code examples, the things that I show are going to be a little bit different from, the average code example that you find online, because of that time and iteration spent with this topic. One of the things, though, I had coming into it is I came from the world of C#, and specifically the world of Windows Forms and WPF, Windows Presentation Framework. In the C# world, there's something called a background worker. And the whole idea of a background worker is to run tasks in the background. So you have communication between the front end and the UI, and work that needs to happen in the background. Background worker and async task are very, very, very similar. They have an awful lot in common. I will say that background worker in C# was a lot easier for me to learn, and I did learn that before I learned async task. So, some of the things that I kind of pulled, I do have some kind of cross-pollination between those ideas. The other thing to say there, because of those kind of similarities, it's more than likely whatever language you end up working in, whether technology you end up working in, whether it be Android, whether it be C#, whether it be JavaScript, or whether it be Python or something else, you're probably going to have some version of this concept in that UI framework. So this is not a specifically Android thing. We're going to talk about the Android approach to it today. But a lot of these techniques and a lot of this guidance really is universal between almost any technology. Because if you're writing a UI, at some point you're going to find that you have things that take a long time and therefore need to be offloaded to the background thread. And that actually turns out to be the three things I mentioned here: files, databases, and internet. All of those take time. They all need to be offloaded, usually some way. So you'll find equivalents of this in a lot of different technologies and frameworks. So as I mentioned, Windows Forms, the equivalent class here would be the background worker class. If you're working in Swing, which is an older UI framework for writing desktop apps in Java, there is a Swing worker class. Actually has a lot in common with async task as well. Versus in JavaScript, oftentimes what we end up using is promises. And go back to your previous question, Paul, about async await. Well, async await underneath the surface uses promises. So promises are kind of the answer there in the JavaScript world. But promises actually have a very different behavior and implementation than what we do here. And one of the gotchas, though, in promises don't actually spin up a background thread. The async await and promises give you a way to put your work to sleep, but all of your code that you're writing when you're dealing with promises or async await, it's still happening on the main thread. It's still singly threaded. So it's not exactly the same as what we're doing here. Okay?
Yeah, I'll have to see it once it gets started. I kind of think of this as if we're going to use that restaurant analogy like we did before, where this, not background worker, but it's just cooking up the food in the kitchen while I'm just sitting at the table and chatting or whatever. Well, the user is using the application. Meanwhile, this data is being retrieved from a database, or there's an internet query going
something's
on.
happening. Yeah, so something's happening in the kitchen, but it doesn't exactly follow that same analogy because it's a different setup. So it's more like you have this async task sets up a duality between like the server that's serving you your food and delivering your thing, and you've got the cook in the kitchen who is making your food. So Asynctask basically gives us a communication mechanism between your server at your table and the cook in the kitchen, is basically the way to explain it. It gives us a communication between those, but not in the same way that promises do. So let's talk a little bit about terminology. So kind of working our way down to the operating system terms, and you'll remember that at some point that I mentioned that Android is actually based on top of Linux. Linux is a very popular operating system for a lot of things in the software community, mainly running servers, but all Android phones are actually powered underneath is Linux. There is a version of Linux underneath all the Android stuff. We don't tend to need to get very close to that. We tend to be pretty far separated from the actual underlying Linux kernel, but sometimes it will hit you. And so this is part of where, you know, maybe we're touching a little bit on some Linux or operating system concepts. So a process is an instance of a running program. That's what we call a process. So for instance, if I'm looking at my applications that I have running on my start menu right now, I have OBS running, I've got Android Studio running, I've got Discord running, Chrome. All of those are separate processes. They're running programs. Or in this case, I have 2 File Explorer windows running. Both of those are separate processes. In the world of Linux, every process has a process ID, and that has to be different. That does become relevant if you ever need to get into managing processes or killing processes. You may need to find out those process IDs. It's worth noting that processes, and this is regardless of what operating system you're running, whether it's Mac or Linux or Windows or some other flavor, processes do not share memory. So whatever variables you have in one process, they're not accessible. You have a different copy of it in another process. Okay. So that means things like static variables or constants. We usually assume, you know, a static variable, there's only one instance of that. That's not true when you go to multiple processes. So if I have a variable that's declared static, I will have a copy of that in each process. It's not unique. It's not singular. So that means if I get into a situation where my application forks up 2 different processes, one process that's doing this and another process is doing something else, that means that things there that you might assume to have one copy, there's actually 2. That becomes very important. And so one of the things that, you know, that kind of leads into, because static variables are not unique, because they're only unique to the process, I would generally recommend you against using static variables at all anywhere in Android, except for constants, things that literally never change. Everybody with me there?
Like when passing intent, you mean the stuff that's in all caps?
Yeah, some of those constants. Well, and namely those are like primitive types, integer, bool, string, or strings. Those are acceptable things to have there because they're immutable. You can make them immutable by making them static final, but you have to be very careful of that because that can get you into some gotchas. We had when I was working in the industry, we actually had a problem in that case because we had 2 different apps that were communicating to each other. Basically the way it was set up is we had the one main app that we were developing, and we had a secondary app which actually updated the first app, which pulled down the latest version from the internet. And so those 2 apps needed to communicate. There were some variables in there that were marked static, but as it turned out, those 2 different apps had a different version of what was in there because they were separate processes. And that actually created a lot of pain because that would previously been the expectation. Is like, well, I can mark this static. There'll only be one copy of it. Implementing something called a singleton pattern, which the idea of a singleton pattern is to only have one copy of it, but it relies on a static variable. So all that being said, take away from there, don't use static variables. You will regret it later. So it's worth noting, so by default in Android, all your components operate on the same process. That's the default. If you don't change any of the default behaviors, you'll get that out of the box. All of your stuff will be running, your whole app will be running in a single process. And, say Facebook is going to be its own process, and your Google Chrome is going to be another process, etc. But your app is just one process. It's generally recommended that you don't change that behavior. It's generally best to not spin up additional processes on Android. So while you can do that, there are ways to do that. There are ways to fork your application into multiple processes. You should really not do that for a lot of different reasons. Part of it is it just consumes a lot of memory. Secondly, because they don't share memory, you can get into some other gotchas there. In the Android documentation and their APIs, sometimes they use, sometimes they use the word process, sometimes they also use the word task, and I put that in quotes because what they mean what they mean in that context, task is not the async task that we're talking about today. So sometimes you'll see the term task in terms of if you look at your running programs. So let me pull up, I don't have my emulator running right now, but I want to pull that up here. So if I say I've got this app here, I can see the running apps, right? So these are separate processes, okay? Oftentimes, these also get referred to as tasks. So here's a task, here's a task. So in this context, you'll sometimes hear it, the documentation refer to those as tasks, although really what they mean is processes. Okay?
They're 100% interchangeable.
No. In this context, right, we would call this a process or a task. Both of those terms are used here. But the term task actually is used a few different ways in the Android world. So a task does not mean a task necessarily.
This is one of those things like all snakes are reptiles, but not all reptiles are snakes.
Something like that.
Okay.
There's at least three different ways that I've seen the word task used in Android. So be wary of that. So one usage of this is a task. Another usage of the term is, an async task like we're talking about. Another usage of that term task is a job, a thing that needs to get done. So that term task is used a lot of different ways because as far as going back to English, a task is just something that needs to be done or a job. So you'll see it in a lot of different places there because of that kind of going back to English as a more general meaning. So when we're talking about async task, this is not what we're referring to. Async task is not a process. The next term that you'll want to know is threads. And so a thread is the smallest execution, a thread of execution is the smallest unit you can use for processing, for running your code. A process or running application can have multiple threads. So for instance, here you see, hey, I've got one process, and that process has spawned up 4 different threads. Each of those different threads can be executing code concurrently or at the same time. So one of these threads might be paying attention to what you're doing on the front end, like scrolling through your Facebook feed. Another thread here might be grabbing images as you're scrolling through your Facebook feed and downloading those images. And maybe there's another thread. Maybe this thread is also downloading images. And maybe then there's a fourth thread that, again, you're scrolling through your Facebook feed. This one's going to the Facebook servers and getting more posts, right? So all of this stuff can be happening at the same time, oftentimes without the user really realizing about all of the different threads that are going on, okay? So you can have a lot of different threads. Each of those threads can be running code at the same time. It's worth noting that short threads do share memory. Unlike processes, which don't share memory, processes do. So that means if you have a variable that all of these threads can access, they can potentially all read and write to that same variable. And read from it as well, which can cause some problems in terms of timing if you're not careful, especially if they're expecting one thing happens before another. That can be a really big gotcha with threads is timing. And one of the things that we talk about race conditions. Race conditions is anything where the timing or how things operate is dependent on who gets there first. And so that's a big gotcha anytime you're introducing additional threads. Regardless of how you introduce threads to your program, you have to be very, very careful about the fact that they're sharing memory. Okay? All code, regardless of what language or platform you're writing it in, is going to run and execute within a thread. That is regardless of if you're writing it in Java or C# or Kotlin or Python or JavaScript, it's always running within a thread. There's no way around that. Like that is how we run code, is it runs within a thread. Most technologies support multi-threading. You can have as many threads as you want up until you run out of memory. With the world of JavaScript, we didn't talk about this too much because JavaScript is primarily a single-threaded environment. There are some newer ways to potentially spin up more threads, but typically you just have one thread. And so you don't necessarily have to deal with those communication and race condition issues as long as you have one thread. So by default in your Android applications, all of that code is going to run on the main thread. And this is kind of universal regardless of, again, whatever technology you're running with. Typically, you're just going to start with that one main UI thread. And that's all we've done so far. We haven't offloaded anything to a background thread with what we've done this course so far. Okay, so if you think about all that code that we've written, right? All of those lines and lines of code with the recycler view and other things, form validation, all of that's running on this UI thread. Now, this UI thread is in charge of a lot of things. It's a very busy thread. It's in charge of monitoring for user interaction, saying you touch the screen, you perform any sort of gestures, you're typing on the keyboard. It's in charge of monitoring for those events and watching the sensors and dispatching events like, hey, here's a key press or a click event or a selection change event or on interaction listener, yada, yada, yada. Every event that you could possibly want to listen to, those are all dispatched from the UI thread. UI thread's also in charge of rendering the UI. Or if the layout needs to be changed because you've changed the size of some elements, or you have changed the size of some UI widgets, or you have hidden or shown a particular control. Maybe you change the visibility. All of that is the job of the UI thread. It has to do all those things. It has to launch and destroy activities. Has to play animations and transitions and video. And as we'll talk about next week, sending and receiving broadcasts, which is messages that are going back and forth between potentially you and the operating system, or parts of your application and other parts of your application. All of that is done by the UI thread. Okay, so the UI thread is a very busy guy, and you should do whatever you can not to block it from performing all its other duties. Okay. Because as long as your code is running, it can't do any of the other stuff. All that other stuff gets put on hold while your code is running. Is everybody with me there?
Yeah.
So, in Android, there is a very well-known dialog called the Android Not Responding dialog. We call it an ANR because it comes up so often. While your code is running on the UI thread, as I mentioned, the system can't respond to any other user interactions. It can't do anything else. It's blocked. It's stuck. If your code that you're writing takes longer than 16 milliseconds, then that's going to mean that the user's going to notice a jerk in any active animations or transitions or video, because that pushes it beyond the 60 frames per second window. So if you're trying to render, things at 60 FPS, you need it to take less than 16 milliseconds. In reality, your limit is usually lower than that, somewhere potentially around 10, depending on what else is going on in the system. So you have a very, very small limit of what you can do without interrupting other things that are happening on the screen. So keep that in mind. If your code happens to block the UI thread for 5 seconds or more, that limit varies a little bit based on operating system or what the cause is. But if your code is running for more than 5 seconds or more, it's very likely that the operating system will show up an Android Not Responding dialog, which kind of looks like this, right? So remember, towards the beginning of the semester, one of the programs that I asked you to write a program that can figure out, all the prime numbers up to X, right? So all the prime numbers up to 1,000,000. Well, guess what? That takes time. As it turns out, it typically takes more than 5 seconds. So if you tell it to go do that, it's going to go and try and crunch as long as it can. And then about 5 seconds later, you'll see this dialog pop up. Because during that period of time, the user can't click on any buttons. They can't do anything with your app. As far as the operating system is concerned, your app is hung, right? It's misbehaving, right? So it can't do its other work. So it's going to say, hey, something might be up with this application. Do you want to keep letting it work, or do you want to stop it? So you'll see this dialog pop up. Prime numbers is the name of my application, so prime numbers isn't responding. That's where the name ANR comes from. Android Not Responding. You'll see that there's two options: close the app or wait. Okay. Notice that the close the app button is highlighted. Does everybody see that?
Yeah, it's been my experience with any of these that waiting does nothing. It doesn't just start working.
Right.
I don't think I've ever seen a time where waiting was the right course of action and it did end up working in the end.
I have seen I have seen the contrary of that. I have seen a lot of times where it resumes. But I think that what you're saying is the general experience of most users. Most users see this and they come to that conclusion that it will never end. Which is the problem, right? Is your users are going to see this and they're going to assume that, okay, this is never going to finish. I don't want to wait. I'm just going to close it and try it again. Right? That's your usual course of action.
Wouldn't it be better if the pop-up said like it's taking too long to load or something? Because not responding seems like it's giving a bad impression. Because like you said, if we're doing the prime numbers and it takes a long time, the operating system says it's not responding, but in the background it's still trying to finish up.
Right.
Is that like?
So it gives that bad connotation. You're right, and it's supposed to. It's actually supposed to give you that connotation that something's busted. That is the intent. You cannot change how this dialog looks. This dialog is completely outside of your control. You follow with me, Corey? I can't change that text.
I'm just saying, like, I feel like when the operating system says that it's not responding, but it's just working in the background.
Yeah. So your goal as a developer is that this dialog should never appear. That's our goal. Our goal is we never want this dialog to show up. So the default thing that comes up, the default option that's selected is close app. Most of your users are not going to wait more than a second to just click close app. Because yes, they have that expectation. They see this and they say, oh, it crashed, right? That's what they see when this pops up, is that they crashed. Or if they read any further, they're going to think, oh, it's never going to come back, right? So they're typically not going to wait. They're just going to hit close app immediately, okay? Because they don't know that, for instance, hey, finding the million prime numbers, they may not not know that takes a long time, right? They may not know that. In this case, it's kind of obvious, but most of the time, it's not obvious to users what takes a long time. Okay. So if this comes up more than once, like, as I said, the users are typically going to just say, okay, it crashed. I'm going to go back and try it again. Right. Maybe this is, posting something to your Facebook feed, or this is, trying to, order wherever social media platform, or this is trying to post a video. Well, uploading video takes time, right? So if your users get this more than once, typically they're going to just give you a bad review, uninstall your app, and never come back. That happens a lot. Everybody with me there?
Yeah, I think that's pretty reasonable.
Yeah. That's the user's usual way to solve this, is say, give you a 1-star review, uninstall, I'm never coming back, you've lost them, they've gone to their competitors. And they will recommend their friends to also leave you as well, sometimes. So you really, really, really do not want this dialog to come up ever. Okay? Everybody with me there? So what we're talking about today is how to use this class called Asynctask, and how to use background threads in general. If you do it right and you offload your work to background threads, this dialog will never appear. If you do it right, this dialog will never appear, because you'll have control over when things happen, and you won't be blocking the UI thread for 5 seconds.
Mr. Smith, is there a way to force that to show up, like create conditions so you can maybe not wait for it by happenstance? But I don't know if I'm being clear about it, but
the answer is yes. Yeah, the answer is yes. And remember that I said all of your code runs on the UI thread. Okay. By default. So that's really all you have to do is make your code take 5 seconds or more. That's it. So that means doing something as simple as writing a loop that goes through 1 billion iterations. Okay, that's probably going to take longer than 5 seconds, as long as you're doing a little bit of work inside there. So that just may mean a loop that's very long. Or another way to do it is you can do something called putting the thread to sleep. Putting a thread to sleep says don't do anything for a period of time. Just go to sleep, and we'll let you know when and we'll wake you up in X number of milliseconds. So you can just say, well, let's make the main thread sleep for 10 seconds. That's all it takes to get the ANR to come up. Does that make sense? So a really big loop, or just putting the main thread to sleep. That's all you need. So it's pretty easy to cause this to come up. So given that, what we want to push off to these background threads, or anything that's long running, right? So 16 milliseconds is that point in time where you want to say it's already worth it pushing it to the background thread, and you should. If it's even just 16 milliseconds or longer, it could be sometimes. That's it. Obviously, anything that's taking anywhere near 5 seconds is something that needs to go off there. So things that would be considered long running, where you usually need to do this, can be loops. Even if you have a simple for loop, it can take a long time if you're, say, needing to go through 1 million records. If I need to say, let's get 1 million records from the internet, or let's deal with a million things or generate a million random numbers, that could take a long enough time to get you into that 5 second mark. So loops can be any for loop is something you should look at with suspicion and consider maybe even that needs to be pushed off to a background thread. Any sort of long calculations that you have, such as finding a bunch of prime numbers or finding the millionth element of the Fibonacci series, or trying to do anything with neural networking, machine learning, AI, a lot of things that you might do with game development, whether it be pathfinding or different things. There's a lot of things that, in terms of calculations, that can take a long time. And honestly, if they're going to take a long time, they're usually a loop embedded in there. So that kind of long calculations kind of are bundled in with that first case in some case in general. Sorting also is one of those. If you want to sort 1 million elements, that takes a very long time. That sorting can be enough to say that's something that needs to be pushed onto the background thread. Okay? File I/O, whether I'm reading files, writing files, all of that takes time. It takes long enough in most cases to be beyond that threshold. Beyond the 16 millisecond threshold is pretty much universal, even if you're reading and writing small files. It also changes based on how good the hardware is, or how busy the hardware is, how full it is, right? So for instance, if you have your user, they have maybe 1 megabyte of storage, reading and writing files is probably going to take longer than if they have, say, a megabyte free versus if they have 4 gigabytes free, right? So if they run low on space, that's going to be one thing that slows down your file I/O. There's a bazillion things that can slow down your file I/O. So anything you do with file I/O needs to be on a background thread. If you're using external devices or sensors, that also is stuff that you need to think about pushing to the background thread. So let's say you want to hook up with USB devices or Bluetooth, maybe a Bluetooth keyboard, Bluetooth external hard drive, working with the GPS. The GPS takes time to get locked. And do work with GPS. Sending things to a printer to be printed, which is not necessarily a very common thing on Android, but it does still happen. All of those things take time, right? So if you're connecting with those devices or those sensors, you need to be aware of that. Anything you do with the network, doesn't matter how you're connecting to the network, doesn't matter if it's at the user's home, it's across, or if it's across the country or even across the globe. All of those things take time, and you should budget for them as if they're going to take way too long enough. Anything that's related to the network will eventually take long enough to cause an ANR. So there's no network stuff whatsoever that you can do on the main thread, or that you should do on the main thread. So whether you're communicating over sockets, HTTP, Wi-Fi, communicating with your database, all of those kind of things need to be on the background thread. Okay? Any questions?
Nope.
Okay. So let's talk about the Asynctask class now, finally. So the Asynctask class is inside the package Android.os, and you can actually look at it in the Android API documentations themselves. You can kind of read up on that class and see how that operates. Async task is an abstract class, which means that you do have to make a subclass for any work you want to do with it. You can't use the async task just out of the box because you can't even create an instance of it. So for every little thing that you want to do with it, you're going to need to create a subclass. And as I mentioned earlier in this lecture, that usually means having a lot of subclasses of async task to do different things. It is a generic class as well, which means that you have to provide a few different type arguments. In this case, it's actually 3, which may seem obscenely high because, so far if we're just dealing with things like list, right? List only has 1 generic type argument. There's 3 in here. So the 3 that you need are parameters, progress, and result. Okay, so parameters is meant as a way for saying here's the data type of the input. Progress is for data that you're going to publish periodically as the task or as the job runs. And then your result is the data type that you expect to have at the end as the output. So you can think of it as input, kind of intermediate, and output. It comes in that order. Okay. Oftentimes, you don't need to do anything with several of these types. In which case, you can use the word void to substitute in there to say, I don't care about parameters, or I don't care about progress, or I don't care about result. You can put void into any of those type arguments. Now notice that it is void with an uppercase v. Okay, normally we write void with a lowercase v, but this is void with an uppercase v, which is odd because it's not the void that you're used to. This is void as in the class void. Starts with an uppercase V. So there actually is a class called void. That's what we're putting in here. The reason we need to do that is because we can't put primitive types into type arguments like lowercase void. So we have an uppercase void. And really that just says I'm not going to use that. I'm not going to use that part of the interface. Okay?
So it would be a substitute for, say, like progress.
Right. It'd be a substitute for any or all of those. Believe it or not, sometimes I put void, void, void. Sometimes, and I believe this is in one of the examples I'll show you today, I put void for all 3 of these.
It would seem like you would need something, a parameter, params, and a result at the very least.
Sometimes you don't need any of those. Sometimes you don't need any of those. What I will say, I nearly always put void here. And yes, it's often that result will have something non-void, but sometimes you don't have a result either. That happens too. So, don't discount and don't expect that you need to put a value in all 3 of those things, right? Don't expect that you have to. Okay?
Okay.
So, looking at kind of a simple way of subclassing this and starting to look at what the interface looks like. If I'm creating a class, I'm going to say here, I'm saying private class. We'll come back to why the word private's there. I'm calling this my task, and I'm going to say it extends async task, params, progress, and result. Now, I need to actually put some types in here. I'm not doing that in this case because I want to kind of show you where those fit in. So I might fit in like string or long or list of products. I could substitute it in for those. Those appear different in different places as you override the methods. Typical rule of thumb, if you're going to write a subclass of async task, it should have a constructor. And more than likely, that's where you want to take your input. I generally take all of my input to the constructor and just leave parameters as void. Because I find that is a lot more intuitive and a lot more flexible. Okay? So usually I put my input data into this constructor, and that's what I would advise you to do, and that's what all my examples do. So I don't actually use this params. I just set it to void. On pre-execute, this is a method that you can override, and that basically runs before your background thread. And then you've got on post execute, which executes after the background thread. On progress update is as you're having little changes in between, and do in background is actually where the grunt work of this async task works. The only one you have to implement, the only one you have to override is do in background. These other three are optional, right? So do in background is required. The other ones are completely optional. Now you'll notice in do in background, you see I get params ... as the input. So what that means is, for instance, if I put in string up here, well, then this would be string ... So the type of these signatures are going to change based on what you put here in the type arguments. Okay? Everybody with me there?
Yeah. Is it going to be like that private whenever we set these up? So the async task has the subtask called my task, and that's always going to be private. And then the input coming in, my task is public.
No, my task is a subclass of async task.
Okay. If I didn't say that, that's what I meant.
Yeah, this is an access modifier in here. This can basically, it's going to be one of two things. It's typically going to be either public or private. And we'll talk about here later why I usually make that private. But ignore the access modifier on here for a second.
Okay, and one more thing. On the second line, it's public my task.
Yep.
Our return type is my task.
That's
that's
my constructor, right? My constructor is marked public.
That's your constructor. Okay. All right, I'll just hold my questions till we do the real code. I think it'll come clear then.
Right. So those are the four methods that you have to implement, and basically the important thing there is that they change. So you're going to have parameters, you're going to have progress, you're going to have result. I will mention one thing here. Android Studio actually does a weird thing. It does a problematic thing that it shouldn't do, but it does. Anytime you override these methods, it will actually suggest the wrong name for these function parameters, these function arguments. So for instance, typically the way that the Android Studio generates the code, if for instance you have void here as the parameters, it will suggest the name as being voids. Or if your progress is a void type, it'll recommend it as void, or your result type is void. It will recommend void as the name, or if it's string, it will represent as string as the name. Please don't take the default names on any of these methods. You'll want to rename them to params, progress, and result, please. Because the naming it based on the data type, which Android Studio does, is not helpful. Is not what you want. Okay? So that's one gotcha as you're overwriting it, is it won't generate the right names to these parameters. It'll generate it based on the type, which is not what you want. Okay, so those change. So the type of do in background that it takes is that first argument, on progress update is the second, on post execute is the third. So the types of those change based on that. And actually, I have one thing wrong here, because this should be result is actually the return type from do in background, is whatever your result type is. Okay. So async task has a few different methods that you need to know about, and it gets a little bit tricky because you have to think about, well, what are the things that are called from the UI thread, and what are the things that are called from the background thread. So in terms of two methods that you need to know, first of all, async task has the execute method. The execute method is what you call to actually start a task. In reverse, cancel is what you call to abort a task. In all cases, execute and cancel will be called from the UI thread to start and stop the operation. Usually you execute and cancel from, for instance, a button click. So you might have a button to start the task or a button to cancel the task. Also, you typically need to call cancel from your onDestroy method, because when the activity gets destroyed, you need to clean up after yourself. So you'll see this cancel in a few different places. That tells it to abort. One gotcha with canceling tasks: tasks do not stop on their own. Tasks do not stop on their own. They do not magically stop or get aborted. You have to actually make them stop, which comes down to how you write the code. Okay? That's a common case where people miss. They say, okay, well, I'm going to cancel the task when the thing is destroyed, but the task keeps running because they aren't actually checking if the task was canceled. That's a thing that people miss. You do need to, in your task, you need to check in a few different places whether or not the task has been canceled. So it's usually in places like do in background, and on post execute is the most common two places where that needs to be. But if you miss that check to is canceled, you're going to have an application that crashes. Okay? And I've honestly seen very few tutorials that correctly call the is canceled method where it needs to be called. Next method in here that you want to know about, we kind of looked at this. Do in background. This is the one you override to perform your actual work on the background thread. So do in background is the only one in here actually that is where you put all of your code that happens in the background thread. Everything else is actually going to be the UI thread. Okay, that's the one you override for doing the work on the background. So whatever you put inside of there, that will automatically be running on the background. Inside of do in background, sometimes you may need to say, hey, I want to update a progress bar. That background thread cannot do anything with the UI. It's very important. Anything you do with UIs, whether you're updating text views or progress bars, recycler views, adapters, anything that affects the UI has to happen on the UI thread. Does that make sense? You can only update the UI on the UI thread. You cannot update the UI on the background thread.
As a general guidance for how to do this, if there's something that can be done in the background, should we generally be doing that?
Yes, more than likely. If it could be done in the background, if it's going to take a sizable amount of time, you should do it in the background.
Is there anything other than UI interfacing that do in the background shouldn't be used for?
That's it. Like, it can't touch the UI.
Okay, so we got some pretty good guidelines there then.
Yeah, it can't touch the UI. Unfortunately, what touching the UI is actually a lot bigger than what people realize. That's actually the fact that you can't touch the UI limits you down to about 10% of things you can do. Because actually 90% of the things you do in Android will touch the UI. Okay. You with me there, Paul?
Yeah.
So that really constrains you down to things that you can do. So things you can do safely: if statements, for loops, while loops, etc. Any kind of loop, typically okay, as long as you're not looping over UI elements. So like if I'm looping over text views, well, you're touching the UI. If I'm looping over a list of products, that's okay. That's not a UI thing. But if I'm looping over an array that has text views inside of that object, again, you're touching the UI. So it's very easy to, I will say it's very easy to accidentally step over that bound and accidentally miss something where you're touching the UI accidentally. One of the things that means is very, very, you want to be very careful about calling methods. Because more often than not, you call that method may actually be used in more than one place, as methods are. Methods are often used both on the background. You might have a method that, is intended for use on the front, on the UI thread. Well, you can't then also call that from the background thread. So you have to be very careful about contaminating your methods, where you may have a method that's dealing with the UI but also doing some calculation. That's an area where people get caught, is they say, I'm going to call this method to go do the work, and then later on somebody changes that method to do UI work, and now your task is broken because they made another change somewhere else. So typically in doing background, you should be suspicious of any method you call, and it's usually better to inline it rather than calling another method. Okay?
Yeah.
So that really limits, all of the code you need should be in doing background. Publish progress. So if you do have a place where you need to update the UI, you don't update the UI and do in background directly. Instead, you call publish progress, give it whatever data you need, and then that will send the data over to the UI thread where you can work with it. So in doing background, you'll call publish progress. It can take some data. And then over in on progress update is where you're going to actually update the UI. So if you have a progress bar, you need to say, okay, I want to set to 50% when it's 50% done. You don't set the state of the progress bar and do in background. You just say publish progress 50%, and then over in on progress update, that's where you actually update the UI.
I got a question. So is that expensive in terms of memory and all that? Because I realize you don't want to leave your user hanging.
Okay.
Because then they'll just quit or go to something else. But making sure the user is satisfied is more important than the cost of memory.
The cost in memory of async tasks?
Well, like for example, the progress bar, that's interfering. That I'm using the UI there, right? So that would mean that.
Well, that's what I'm saying. You can call publish progress from doing background, but you can't update the UI itself. So what publish progress does is it basically creates an event, which then is fired later on the UI thread.
Okay.
So publish progress doesn't immediately update the UI. It says, here's some data, and then the UI thread will get around to it when it has time. So this part runs on the background, this part runs on the foreground, the UI thread. So you've got, that's where that happens. So the other three methods that you can implement or override, you can implement on pre-execute, on progress update, or on post-execute. All three of these are optional. You don't have to override them, but oftentimes you will find some useful stuff that you need to do. So on pre-execute runs before do in background. On post-execute runs after do in background. And on progress update kind of runs in the middle there every time you call publish progress. But those three methods are where you do the actual UI updating, is on pre, on progress, and on post. Those are the places where you can update the UI. So basically what you end up doing is moving all that logic that needs to touch the UI out of do in background and over into one of these three methods. Does that follow?
Yeah. Thank you. Mm-hmm.
So let's talk a little bit about these three parameters. So you've got three type parameters. You got params, progress, and result. So params being the first one, that's what you pass into the execute method. When you start the process, you're going to call execute, and inside of execute, you can pass some data. That data will then be later read in do in background. So you pass the data in to execute, you read it in do in background. Always make that void. In my experience, it's always, always, always better to provide that data via the constructor of your task than providing it via this route. This route is basically always the wrong choice. So I'm going to do void instead, because you usually end up making more work for yourself if you use something other than void. Okay? So I'm going to make that as void in all my cases. Progress. Progress that's the type that you pass in to publish progress, and it's also the type that you read over on progress update. So remember, this is in the background thread. This is in the main thread. Okay, but they both have to agree on the same data type, which is why it's a type argument here. And this is data that you're going to use to update the UI as the task runs. Again, progress bar being the most common, but it can be other things as well. So generally speaking, oftentimes this is going to be void, because a lot of times, most of the tasks you need to run on the background thread, they're actually usually going to end up running fast enough that trying to show progress along the way would actually not be worth it. If you're going to say that your task runs in 5 seconds, it's generally not worth it to publish progress along the way. You just say, okay, we'll just show a spinning dialog that's just the little spinner thing that's going to be spinning until it's done, and then that thing will go away. So for a lot of things, it's fast enough that you don't need to show progress as a percentage, say, but you do want to run it on the background thread because it's longer than 16 milliseconds. Does that make sense? So there's a window in there where a lot of things fall where you don't actually need to publish progress. So it's only the things that are longer running that you need to publish something for. A lot of times people use float or integer or long, especially if they're doing some sort of percentage on the progress bar. So from 0 to 100, you might use a number there to kind of publish how far along you are. That number doesn't necessarily need to be between 0 and 100. In fact, usually I do the calculation of what the percentage is over in on progress update and not in do in background, because I don't want to make do in background take longer. Versus that calculation is pretty quick to do. I can do that back on the UI thread. So usually I just give some number that says here's how long we have, and do the actual calculation of the percentage and showing that on screen over in the other method on progress update. You might also send a string there. So for instance, if you have a message that you're showing where you're saying, oh, I'm working on this, I'm reading this file, or I'm copying this file, or I'm going and receiving this image now, that might be a good place where you need to send a string over. Now it's worth noting you can only have one value for progress, right? You can only have one data type there. Okay? And oftentimes, in fact, you may need to publish more than just a single thing. So for instance, I might want to say I am 50% done, and the current thing I'm working on is copying file X to B, X to Y, right? So that would be a string plus a long. Is everybody with me there? Or a string plus an integer. I can only provide one data type there. So how do I solve that? How would you resolve that if you need to say, well, I only have one data type here, but I need to pass two things that are different data types?
Would it be in the constructor?
Mm-mm.
An object?
Object, okay. How many properties can an object have?
As many as you like.
As many as you like. And do they have to have the same data type? Nope.
Well, within it, you can make it what you want, but the object is an object.
The object is an object. So a lot of times what I end up doing for the progress, especially as my applications get bigger, is I actually end up usually having to create a special object there that contains the data I need. So I might have like a download file progress event or progress data. And so that's what I would then put in there is download progress data. And that's what I would be sending back and forth if I need to send more than one thing. Okay. So Realistically, that progress can be almost anything you want. The one gotcha there is, like I said previously, you don't want to be working with the UI components itself. So one of the things that means params, progress, result, none of those should include views. You should not be passing in views to any of those 3 parameters. Does that make sense? So text view is always a bad choice for any of those 3, because it's a UI component. That is the limitation, right? So as long as it's not a UI element, not a widget, then you're okay with passing it around. That, by the way, when I say UI thing, UI widget, I also actually include adapters in there. Adapters effectively are UI things, because they do have direct references often to like the context or the views, and so they're not a candidate for passing around in those. Finally, the result. The result is what you expect to have at the end of this operation. So, for instance, if I am doing a calculation, trying to find all of the prime numbers from 1 to 1,000,000, well, the result there would probably be a list of integers or a list of longs. If I'm trying to sort a list, well, then that would probably be a list of things, right? So if I'm trying to sort a list of products, then I would return as the result a list of products, right? That would be the sorted result of that. So that result can be a lot of different things. There's not really a standard, like most of the time the result is this. The result is really whatever you need it to be. And so that result there, you're generally going to, again, use that data to update the UI after the task is finished. So it can be whatever type you need. It is the most important of the 3. The result is your most important. Most of the time, params and progress, you can just make them void, forget they exist, but your result 90% of the time will need to be something other than void. Okay? Questions? Yep.
Well, it looks like we're at the end of the slides. I was seeing if we could take a break.
Okay. Let's wait until we're actually done with the slides.
Oh, okay. I thought. Oh, I see it. All right.
Yeah, we're not there yet. So, as with the other 3 types, params, progress, and update appear in 2 places, and basically you're going to have one that's on the UI thread and one that's on the background thread. The result is the same. So the result is returned from do in background, and then it is passed in to on post execute. So it's returned from one method and passed into another method. So before we kind of get into the code example and take a break here, in Java, there is something called a nested or an inner class. So far we've made regular classes where, like, hey, I've got the main activity is in the main activity file. Or I've created what we call anonymous classes, where I've just said this class doesn't even get a name, but I'm going to use this to make my listener for onClick or onEditor action listener, or when you select an item or when you pick a radio button, all of those kind of things. Those are anonymous classes. But there's another way to define a class in Java, which is known as a nested or inner class. And this is where you define one class inside of another class, okay? And there's some magic in Java in how that works. In fact, if you have a nested or inner class, that class gets direct access to all of your private fields and methods in the class that you've declared it inside. So you don't have to pass any of that data around. You don't have to declare that as additional fields. You don't have to make things public. You just leave things as private, and it can access all that stuff. This is tremendously useful as we're building asynchronous tasks. This is really, really helpful in terms of making sure that we keep our encapsulation intact, because if you make something as a separate class, you usually end up finding yourself making things public that shouldn't be public. Okay, so this allows you to keep things private that need to stay private, and so this is really important to getting your encapsulation right. Again, this is one of those areas where a lot of tutorials get it wrong because they break a lot of encapsulation and they break a lot of connections between the activity cycle and the task. So the activity is not, destroyed or aware of things when the activity needs to be destroyed, right? The task needs to get destroyed also if the activity is destroyed. So you can create them, these async tasks, the subclasses, you can create them as separate distinct classes. So for instance, if I want to have a find prime numbers task, I could potentially create that in a separate file. But usually it's better because they're going to be so tightly coupled with the activity and the UI. It's usually better to nest them inside of the activity class. So what that means is all the examples I'm going to show you, the task, the code for the task is actually going to be embedded inside of my main activity, not inside of a separate file. Everybody with me there?
Yeah, is there all the coding we've done up to this point, like for product and course and cart and all that, that could have been done inside of an activity. It's just cleaner to do it outside.
Sometimes yes, most of the time no. The gotcha is if you nest a class, then you should not refer to it in any other classes. So for instance, product, which needs to be shared a bunch of different classes, is not a good candidate for nesting. Okay, because it needs to be shared. So
yeah, public, in other words.
Public and shared. So you're going to have a private nested class if you have this class that's specific to, say, a single activity. If it's only used by a single activity, then it's okay to nest it. Okay? Okay. Any classes that for sure you need to have in multiple activities, then you definitely want to put it separate. Fair forewarning, nesting classes does come with a little bit of a memory hit, potentially, as well as because you're implicitly have a reference to the object that's inside. So there's an additional just 4 bytes of memory there that comes with a nested class, but that's worth it for async tasks. It's so much worth it, so cheaper that's so much cheaper than doing it separately, actually. But for most things like product, that would be an additional cost that wouldn't be worth taking. So there's a very small cost in memory, as well as some other things there, which means that like all the classes that we've created as separate classes up to this point, like they needed to be separate classes. That's why we haven't talked about this yet. Does that make sense?
Yes.
The classes that we've done so far wouldn't have benefited from this. The one exception to that is sometimes I do actually nest my adapters inside of my activities. Sometimes I won't create those as separate files, because sometimes that's also worth it. Okay, so the things that I generally nest are going to be async tasks, sometimes adapters, and actually receivers, broadcast receivers, which we'll talk about next week as well. So those are kind of the 3 things that I end up nesting. Okay? All right, so I've got a few sample apps I want to show you and walk through, and this is going to give you some code examples of how this looks. We'll do that here after a break. The reason that there's more than one example, as I mentioned at the beginning of this, is that there's a lot of different ways to use async task, and I think that just looking at one code example would really underserve you to kind of understand some of the extent and some of the different ways and tools and things that the ways that you can utilize this, because it's pretty expansive. Okay. All right, so let's take a 20-minute break, and we'll come back at 2:20, and we'll walk through these code examples.
All right.
Okay, so with the prime numbers project pulled up, I'm going to go ahead and push this over here, run it on my emulator. And pull that over. So this is a pretty simple project. You know, basically what you would have done before, and this project in particular is not using Asynctask. It's not using any background threads because I want you to see, you know, how things operate without it. So pretty easy in terms of like there's no network access that's happening here. There's no files that I'm reading. It's just a matter of if I want to do this for a large number, it takes a long time. So, you know, if I'm looking at my layout, kind of working back from there, you know, my layout's just got a few controls on it. I've got a text view for the instructions. I've got an edit text where you can type in a number. I've got a little run button here, and then my results are just appearing inside of a scroll view and a text view, right? So I'm just outputting the results to a text view. So if I say let's type in 10 and let's go ahead and hit done here. Okay, 357. Let me go to maybe 100 and I'll go hit done. Okay, you know, and that basically completes almost automatically, right? As soon as I hit run, it's basically done. If I go up to 1,000, I can still hit run, and basically it's by the time I get there, it's already been done. There's no big notice in lag as long as I'm working with small numbers. But as I start increasing the numbers, and you know, maybe I go closer to, let's say we do 100,000. Okay, I'm gonna hit run. All right, so now I see with 100,000, I see a noticeable lag where things freeze and I can't do anything, and then it comes back. Okay, so it's noticeable, but I didn't get an ANR. Everybody with me there? It's noticeable, but I didn't get an Android not responding dialog. But if I bump it all the way up to, let's say, 1 million, okay, now it's chugging along, right? But I can't click anything, right? Whatever I click, it's just like, I'm busy. I can't do anything because the main thread is currently occupied. So eventually, you know, this is going to come up after a few seconds. It's going to say prime numbers isn't responding. Do you want to close the app or wait? So if we wait, it will eventually go away on its own and actually will get to the end. But this is not a user-friendly experience, right? So everybody with me here on this?
Yep.
So this is like what you would have done for maybe the lesson 2 labs or so. We talked about how to do some of this. This was actually one of the lab assignments. But if I put in a large number, you have this problem where it just freezes out. I do want to give it a minute here maybe to complete, if it will. But we should see that dialog disappear. So while I'm waiting for it to go, I want to walk through the code a little bit and just see what's going on. So in terms of the code, we've got the Oncreate method. Oncreate's pretty simple. We just say find view by ID, get the 3 controls, and then I'm hooking up an editor action listener just so that on the soft keyboard you can press done or enter on your keyboard. If you're using your computer or your laptop's keyboard, I'm listening for either of those 2 things and then just treating it as if you clicked on the button. Okay? So that's what this is about, is so that you can press done on the keyboard and it'll take you to run the program. Okay? So that goes over to on-click run. In that case, or if you just directly click the run button, this is where it's going to take you. So public void on click run takes a view. All right. So first thing we do is we hide the keyboard, just usability fix. I immediately put in the text running, but notice that text, right? I would tell it to change it to running here. When do I actually see that text running? When does this text actually appear?
When it's finished.
When it's finished, right? I tell it to show that text. That text does not appear immediately, right? Well, the problem there is, remember, the main thread has a lot of jobs. It wears a lot of hats. And so it's the job of the main thread to update and show that text to the UI. So if it never gets a chance to do that, right, you're not going to see that text, right? So as it stands, the first opportunity that it has to show this text is all the way when you get done with this function. Does that make sense? Because you haven't released control of the main thread until that function completes. Everybody with me there?
Yeah.
So that's things you have to kind of be aware of. That's kind of the biggest mistakes that one of the biggest mistakes that people make getting into this. They assume that I tell it to go do something and it's going to go do that immediately, and that's not the case, right? It can't do anything until it has a chance to do it, which means that you have to be doing nothing so that it can go do its own work. So that's the first thing we try to do is we spit out the text running to tell the user that it's doing something. And then we parse the limit, right? So I say, let's make a variable for the limit, which is going to be the number that's there. Let's try to parse it. Oh, and then let's check if the limit is less than 1. If it's less than 1, that doesn't really work. I can't really do some calculations in there. I'm just going to throw an exception. So we'll get down here. So if the user types in something that's an invalid number, or they type in 0, they type in -1, we'll just get down here to this catch clause. We'll say, please enter a valid number, and we'll be done because we're returning. So that would, if they type an invalid number, we're just going to get down here and be done. It's not going to go any further. Okay. Now, the rest of this code, the next thing we're doing is we're saying, well, let's loop through the numbers from 2 to the limit and check each of those if they're prime. If that number's prime, then I'm going to spit it out. I'm going to say append it to the results text. Okay, so we're going to append it to the results text. I'm just going to kind of keep doing that until I've gotten up to, in this case, 1 million. So this loop is running from 2 to 1 million. And then finally, when that finishes, I'm telling it to try and scroll down to the bottom by saying, scroll to x coordinate 0, y coordinate is the height of the text view, which you may have noticed as I was running it here doesn't always scroll to the bottom because it hasn't necessarily calculated the height at this point correctly. It's still the previous height before the text changed. Any questions? So in here, what's the part, what part of this code is making it take so long that the ANR appears?
It's that loop.
It's that loop, right? Why is that loop expensive?
Because we're having the user interface do it.
Okay. Well, that just means because I'm doing it on the UI thread, that just means I'm blocking the UI until it finishes. But why is it taking so long to finish?
It's got a lot of numbers to go through.
Okay. So that's true. It's got a lot to go through. How many different numbers is it checking? Is it just checking 1 million numbers? Is this just going through 1 million iterations? So oftentimes when you start breaking things down into functions, you got to be a little bit careful. So this function is prime, right? That looks like pretty cheap, right? I look at that function and I say, okay, I find out if it's a prime. That shouldn't take too long, right? But if I look at it at what is prime does, notice that is prime is another loop, right? I've got a loop inside of a loop, right? I've got a loop inside of a loop. So I'm not looping a million times. How many times am I looping? How many iterations do I need to go through if I've got a loop inside of a loop?
Well, it would be in this case it would be a million. I guess it would be 2 million.
Worse than that.
A million times a million.
Yes, actually, it's much closer to a million times a million.
Because the second loop is looping through the number that it currently pulled, right?
Right. So that last iteration, right? This is roughly a million. It's actually the square root of a million, but it's still pretty darn big, right? So the time that this takes grows what we'd say it would grow quadratically. Grows quadratically. Or if you think about n as the number that you enter, then it grows with regard to n times n, right? Or n squared. So because the time that this loop takes is growing on a quadratic curve, it takes much, much longer even if you just increase the number slightly. So if I say I have 100,000 and then I go up to a million, right? That's a factor of 10. And if it were linear growth, which is commonly the case, then it would just take 10 times as long, right? To go from 100,000 to a million, if I was just talking about, for instance, just looping through it once, that would just take 10 times as long. But because I've got a loop inside of a loop, and this is growing quadratically, it doesn't take 10 times as long. It takes 100 times as long. Does that make sense? So if it takes me 1 second to find all the numbers up to 100,000, it's going to take me 100 seconds to find all the numbers up to a million. Everybody with me there? Can you see why that's a problem?
Yeah, especially on a mobile phone.
Right. So I go from 1 second, which is fine, well below an ANR, to 100 seconds. Whoa, okay, that's way beyond that 5-second threshold. So I have to be very careful with even just loops like this, especially if I'm going to nest two loops together. That's something we need to move to the background. And it's worth noting on here, as you can kind of see, this is a loop inside of a loop. Anytime you're doing sorting, every sorting algorithm that's out there requires a loop inside of a loop. Everything that you do in terms of sorting, every algorithm that we have is a loop inside of a loop. So that means, just like this, if I go from, I might say I have 100,000 products in my store, and that's fine. As soon as I get up to 1 million, my program no longer works. Does that make sense? If I'm trying to sort the search results. Okay. So this can come up a lot. All right. So there's a few things here, right? So the first thing I can see is obviously that this part, right, this loop, that part needs to go to the background thread. Does that make sense? Everybody with me there?
Yes.
Okay. Now, one of the things with the background thread, remember the background thread can't access the UI, right? So what are the pieces here where I'm accessing the UI?
Line 61.
Line 61, right? Where I'm saying results text append, right? So that's definitely accessing the UI. is there anything else in that loop as is accessing the UI? Does this function touch the UI at all?
Doesn't seem to.
Doesn't seem to. Okay, so I'm safe there. But what would have happened if I said in here, let's say, well, I'm just going to move this check down here, and in here, I'm going to say, let's append the number, right, and in is prime. So now this method basically does two things. It updates the results and tells me if it's prime. This method is no longer pure. Does that make sense?
It's no longer what?
It's no longer pure. It's not, it's now, if I put this one line in here, like without that, it was okay. It wasn't touching the UI. But as soon as I put that in here, now it's updating the UI. Right? So without that line here, it's okay for me to call this method as is okay for me to call from the background thread. Is everybody with me on that?
Yeah.
But if I add this one line here, it's no longer okay. It's no longer okay for me to call is prime from the background thread, because it would be updating the UI. Okay? So, and the way that I kind of describe this, this is basically presentation logic. The rest of this is business logic, but this is presentation logic. So you have to be very careful about not intermingling your presentation logic with your business logic. That's one of the things that a lot of people get wrong. Especially as new developers and even as experienced developers, I see even a lot of experienced developers make that mistake of mixing their business logic and their display logic because it's expedient. It's like, okay, I just changed this one line of code, fine, no big deal. But you have to think about those things. All right. So before we go on to the next example, are there any questions on this program here? Okay. It's worth noting in here as well. Remember, I'm showing the stuff in a text view. Problem with a text view is it has to render the entire thing. So if I've got 1 million, lines of stuff in there, I've got to render that million. I can't render part of it. So another thing I want to do in order to make this faster is I actually want to introduce a recycler view to make it so that I'm only showing the numbers, the data that's on screen. Okay, so I'm going to jump over to prime numbers async, which is another example in that folder. And this one I've reworked. I've taken that original program and I've tacked on a few things. So I built in an async task. I converted it over to a recycler view instead. And I also have added a progress bar in here. So we got a little progress bar that goes across here. It'll start at 0% and go over as the process works. Okay, so recycler view there, and progress. Other than that, it's basically the same layout. Okay. So if I kind of try this out first to just see what's going on, let's again start with small number. I'm going to hit run with 10. And okay, done pretty quickly. Done almost instantly, up to 100. And you can see a snack bar coming up there. Let me just jump all the way up to 100,000. Okay, that ran. You could see it populating and filling in the numbers, right? So it's the progress bar is going there. It's done when it's there. And you'll notice also that the run button becomes disabled, right, as the process is running, so the user can't just like try to immediately make it happen again. So there's that. And if I go like I did with the other program, let's go up to 1,000,000. I'm going to hit run. It's running. And actually, it didn't take very long to complete, right? It actually, in the end, it didn't take very long to get up to 1,000,000, whereas the other program, well, it seemed to be stuck on that ANR for who knows how long. Okay. So this is how we rather like that experience to be, right? We kind of let the user know, using a variety of methods, whether the button's disabled, we got a progress bar, we've got stuff updating, another snack bar, all of that stuff tells the user that something's going on. But in the grand scheme of things, it actually runs faster because we didn't run into that ANR. Because we offloaded things off of the main thread, we actually ended up with a better program. Okay. So let's dive into the code a little bit. We saw the layout. I'm going to look at main activity. You'll notice I do have like a number list adapter and a number view holder. That's just to represent the stuff in the recycler view. None of that's particularly new, so I'm not going to go into that. It's not that interesting. But looking at the code that's in main activities is where the new things are. So just like the previous example, I'm getting those controls, and then I'm registering an event handler on the limit edit input here. And then we set up the recycler view. So we say, let's say, set the layout manager. We're going to set the layout manager to linear in a vertical orientation. And I'm also going to create a quick array of numbers. So this is an array list of longs. I'm going to create an adapter and feed that adapter into, wrap that adapter around the array list of numbers, and finally feed that adapter to the recycler view. So at this point, when the app starts, there's actually not any data in there initially. It starts with an empty list, but it's already been bound up, right? So we just need, if the data changes, all we have to do at this point is just tell the adapter that, well, the data's changed. Okay, so that's that. You'll also notice in here I have a reference in terms of my fields. I've got a reference to the task. So this is my custom task class. It's find primes task. So I've got a reference to that here up in the fields so that I know what task is running and I can cancel it when I need to. So I don't start that task until you hit run, right? So it's not going to start immediately when the application runs. But I do want to make sure that if the application gets destroyed, if the activity gets destroyed, that I clean up and stop that task. So one of the things I needed to do is override on destroy and say, well, if the task is not null, then we're going to cancel it. Okay. So, previously in lesson 2, we talked about the activity lifecycle. We talked about, there's the Oncreate, the onDestroy method. There's the onStart, the onStop. There's the onResume and onPause. We talked about those 6 methods and the different states that go into that. But for the most part, the programs that we've been writing, we've really only overridden the Oncreate method. But you'll remember that I said that these methods are really, really important. And so this is where we start getting back to that, because once we start dealing with tasks and things happening on the background, this is most often where you need to implement those other 5 methods, is to do stuff in response to those other lifecycle events. Okay? So that part about onDestroy is really, really important, because otherwise the task would keep going even after we left the screen. So that makes sure it gets stopped. Okay? So go back to onClick run. There's a lot in common here that's the same as the previous example. We're hiding the keyboard first. But another new thing here. So we say before we want to start the new task, before we do anything else, we want to cancel the task if it's already running. So if, for instance, if I type in 10, I hit enter, maybe I hit 1,000,000. We do 1,000,000. Go hit enter on that. Change this in the midway. We wanted to stop that because I am disabling the button, but I'm not actually preventing the user from pressing enter again. So the user can actually potentially start it up again even while it's running. And that's usually something you want to be just precautious about is not depending on the idea that you have that task there. Because otherwise what can happen is the user can then start two tasks. They're both running at the same time, and you'll get some really weird behavior if you have two tasks running simultaneously. Okay?
What's the difference between that and what's on the on destroy, other than the super on destroy?
Same thing. Same thing.
Okay. You just wouldn't want to call on destroy right there?
Oh, no, you definitely don't want to call on destroy there. Yeah.
But what's different about it? What does that do?
So this part is important. That's part of cleaning up the activity. If I called on destroy here, that would break everything. You would have some major bugs. Yeah. So you don't. Nowhere in the code should you call the lifecycle methods, right? So on create, on destroy, on start, on stop, on resume, on pause. You should never ever call those yourself. You should never, anywhere in your code, is it safe to call those methods. Okay, it's only safe for the Android operating system to call those. Okay.
Okay.
So I could take this code and break it off into a separate method that is just that, right? So like I could say, private void cancel task. Right, I could have broken that off into here in a separate method, and then I could just say, cancel task in both of these places. That would be safe. That would be acceptable.
I get it. I understand the difference. Yeah.
That would be fine. The problem with that is how many lines of code have I saved? In the grand scheme of things, by breaking that off into a method.
No, not much.
Not much.
A little more modular.
Yeah, not much. And typically doing that, you won't save yourself much. In fact, you won't save yourself enough ever to make that worth it, which is why I don't do that. Because now I have to, from either of those methods, I can't just look at onDestroy and know what it's doing. I can't just look at onClickRun and know what it's doing. I have to go over and read this additional method. You see that? And so oftentimes what happens is once you break this off, people start putting additional things into this method, additional things into that message. And before you know it, this method that is right now three lines long is 20 lines long, right? And then it's much harder to tell, okay, well, should I be calling that really, doing that from both of these places? Is that really the same thing? The problem is that those methods tend to get bloated very quickly, so sometimes it's actually just worth duplicating the code, which I would say in this case it is, because it still keeps the code clear. Does that make sense? I think it's clearer to have it duplicated than it is to have it, than to try to remove the duplication. Cool?
Yeah, makes sense.
Yeah. So that's that. Okay, so I cancel the task. We go parse just like we did previously. And here's where things start getting interesting. So here's where I actually want to start the task. So the first thing is I construct a task. Look at the constructor here in a minute. So I say, let's make a new task, new primes task, and then we're going to tell the task to execute. Okay. So we construct the task and then we execute it. It's worth noting that method to execute is really, really important. A lot of times, people make the mistake of not calling that method. And so if I just leave that off and I tell it, no, don't call execute, I can run as many times as I want, nothing happens. Because, just constructing the task, that doesn't actually start the task. I need to call execute to actually start it. Okay, so that's one of those things you need to remember to do, is create the task and then execute it. Another thing I commonly see people do, and I've been guilty of this too, is sometimes I see people do this. New find primes task, pass the limit in there, and then they just say execute. A lot of times I see that. And there's so many Stack Overflow answers and tutorials where they do exactly that. What's the problem?
You can't save it.
Right, I can't save it. Right? I can't save the task. Why is it important that I save the task?
So you can use it in other methods.
Okay.
It wouldn't take long to break. If it's everything you need to do is right there inside the whatever function we're in, that's fine. But otherwise, it's just tough to reach it, pass it, if you will.
You should never do this regardless of how big or small your program is. What's the problem? Let's think about why I needed to save it. So let's say I run with this code here. And I'm going to type in 1,000,000. I'm going to hit enter twice.
Does it create 2 instances of it?
Right. It created 2 instances of it. In fact, it looks like it created a lot more. Because it's worth noting, if I hold down the enter key, it keeps firing that event. So if I hold down the enter key long enough, I may have 100 of those things running now. Okay. Why did that happen? Well, because I didn't save an instance of it, I'm not able to cancel it. Does that follow? If you don't save a copy of your task, you have no way to cancel it. Everybody with me there? Questions? So why can't I just say in here, why couldn't I just say, well, I'm just going to say task equals new task find primes dot execute. Right? Why can't I just fix that and put task equals on there? So, assuming you got the code up, why try that? What is the error that Android Studio gives?
Well, you're running a method on something. It's like it's not an instance. You're not saving it. You have to create it first and then act on it. You can't and act on it. It's like cooking food and eating it at the same time.
Paul,
it doesn't work like that.
You're wrong. That's not true. I can create an instance and then act on it immediately. In fact, that's what I'm doing. So if I say new here, that gives me a new object of that task. I can actually immediately call execute on it. That's okay. But when I say task equals here, the problem is that's saving the result of execute. It's not saving the result of the constructor. Does that make sense? In this way, it's saving the result of the last thing that you do. Is everybody with me there? So chaining like that's okay, but you only get to save the last result. And the problem is the last result of execute. What does execute return? Well, it returns something else. Async task, yada, yada, yada. So anyway, that just means, what it basically comes down to is if you're constructing a task, you're trying to start a task, you actually do need to do that in 2 lines. Construct the task and save it to a variable and then execute it. Okay? That way I have the task later to cancel it. Seems like a minor thing. It's actually a really big thing. As you can see, this thing continues to go. Okay. Any questions on starting the task? Okay, let's skip on down to the actual implementation here. So as I said, I do these normally as embedded classes. So you'll see that this class here, right? Remember at the top of the file, I constructed a class. We say public class main activity, right? So I declare a class there, public class main activity. Inside of this, I'm declaring another class, private class find primes task. Okay. And it is important that it's inside, right? So we can see the different parameters that I've passed. So I've said it's an extends async task. And then remember I had to provide 3 values, right? So the first one was parameters. The second one is progress. And the third one is result, right? So here I'm saying the parameters is void, right? It doesn't need anything to start with. In reality, it does, but as I kind of mentioned with the slides, I don't typically want to pass it that way. So I'm saying it doesn't take any inputs, right? So I'm going to put void there. I'm putting long as the second argument because I'm going to use a long to update the progress bar, and basically I'm going to use the number where we are at in the loop as that. So I'm going to use a long as my progress, and then void, there's no result. Reason being is by the time I get done with doing background, the UI will actually be up to date. So I don't actually need to provide anything as a result. So this is where I mentioned, a lot of times I may end up with voids in a lot of these places because that ends up being what makes the most sense. So if I look at my constructor here, so I have a field private long limit. So that's the limit that they typed in. So I need to keep that number. And I'm passing that into the constructor, right? So those are my initial pieces of data, right? Sometimes that may be one thing. Sometimes that may be multiple things. But whatever data I need to start out the process with, that's the data that I'm putting into the task. Okay. So if my task, for instance, let's say just, for example, was to download an image from the internet, what might I want to have here as the parameters to construct my task if I'm downloading an image from the internet?
I'm sorry, can you ask that again?
If I'm downloading an image from the internet, what might be that initial data that I need?
URL?
Probably URL, right? The URL for the image. And so that would be the data that the task needs to know so it can know what image to actually download, right? So that's where that fits in. The next method I have here is onPreExecute. And remember, onPreExecute executes on the main thread, on the UI thread. So this first method is going to happen before doing background, but it will still happen on the UI thread, which means I can set things up. So onPreExecute is a good place to do some setup. So what do? Well, first of all, I'm going to clear out the list of numbers. I'm going to tell the adapter that the data's changed because I just cleared it. So that will result in all the numbers that were there previously disappearing, the combination of those two things. Next up, I'm going to update the progress bar so it's initially in the right place. So we're going to say, well, the maximum, it goes from 0 to 100. So that sets up the progress bar to have that range that I want from 0 to 100. And I'm going to set that the progress is currently at 0. So those two lines are going to update the progress bar to where it initially needs to be. Next up, I'm telling the run button that it should be disabled. Okay, so you see set enabled. If I set it to true, it's enabled. Set it to false, it's disabled. Right? So this does some setup before I start running things. Does everybody understand that? Does that make sense? So a lot of times that's what you'll need to put in there. Some initial work to like get it set up, show a progress bar, initialize the progress bar so the user knows, hey, it's working. And so they can kind of wait till it's done. You know, maybe if you're trying to submit an order, a good thing to do there would be to disable the order button, right? So that they don't try to order again while it's running. We've got the snack bar here. I'm also showing a quick snap bar saying that it's running while the process, you know, at the beginning of the process, so the user can see that. And so that pops up almost immediately. In fact, if I run it with a smaller number, you won't even, it'll be gone so quick because it's done. But if I run it with a large enough number, say 1 million, so you can see all that stuff happening, right? So the running appears, all of that happens at the beginning of the process. The next thing I do is here's where all the actual grunt work is. So I say do in background, and you'll notice that there's a void here, right? And there's a void here. Both of those corresponds to parameters. This one corresponds to the result, right? So it's not taking anything in, and it's not returning anything. Because I'm going to do the input and the output a different way. So in here I'm saying, well, let's loop through all the numbers. So I'm going to go from I is 2 up to less than or equal to the limit. So I'm going to go up to 1 million, increment by 1 each step. Now, I kind of skipped over a little bit of detail here. You see this in my loop conditions. I'm saying while I is less than the limit and it's not canceled. Everybody see that?
Yeah.
So what that does is every time through this loop, it's checking if it's canceled, right? And so that keeps it from continuing to go even if the task has been canceled. If I didn't put that check in there, then these tasks would keep working even after I canceled them. Does that make sense? So in your do in background, you actually have to check wherever your loop is in do in background, because you usually are going to have a loop. You need to, inside of that loop, always check if the thing is canceled. Does that make sense? Because you don't know when it might be canceled or if it might be canceled. So that's what you have to put in there. So I loop through each of the numbers, and just like previously, I'm kind of checking if it's prime. If it is prime, then I just add it to the list. I don't update the UI here, right? Because remember, I'm in do in background, so I can't say like tell the adapter the notify or whatnot. I can't do anything with the adapter because I'm still in the background thread. But what I do here is I say, well, every 1,000 we'll publish a progress, right? We'll update the UI every 1,000 steps. The reason I do it every 1,000 steps is because otherwise it's just too often. Let me just pull that if statement out and you can see what happens. So if I try this with 1 million and I'm sending progress after every step, you see how it kind of lags out? Because I'm sending 1 million or close to 1 million progress updates. See that? So sometimes you have to cut it down and you can't send progress for every step because it would actually be too slow, right? So I think, Paul, you were asking about, is there a cost to publishing the progress? See, There is one, right? If you create a backlog, but if you can get around that, then it's usually worth it.
Okay, can you explain what is cancel it is again? Because I was doing a Control F5 to see where that was called up. It's only mentioned twice in there, so
yeah, so it's defined in async task.
Yeah, that's what I figured.
Yeah.
So what is it doing again? Just real simple.
So it will return true if the task has been canceled, false if it hasn't. So namely what happens is I call cancel up here. Remember how we had that in the on-click run, on-destroy? Remember we were talking about that?
Mm-hmm.
That marks the task as canceled.
That'll quit it and begin the...
Right. Actually, all it does is it sets the is canceled flag to true. That's all this does. It just sets it to true. So it's your job down here to actually stop the task. That's what this does, is actually stopping the task. Without that check there, the task would actually not stop. So calling cancel really just sets a Boolean to true. It doesn't really abort the task.
And this is pretty much in any do in background, which do almost any loop background. That's going to be one of our conditions, right?
Yes. Not just almost, but every.
Okay, yeah. So double ampersand is canceled, not is canceled.
If not canceled. Yep. Yeah. If you have a loop and you're doing background, all of those loops, sometimes you may have 3 loops in do in background. All 3 of those loops should have that check. So, again, because you don't know when it's going to happen. So all of your loops in do in background need that check. So here, that's why that exists. I'm doing, I say, well, let's say is divisible by 1,000, then we'll publish progress. And so to publish progress, I'm passing I. And so you can see here, I is a long. You'll notice, however, that I have to use the uppercase L here when I'm declaring the types. That's because I can't actually use primitives here, even though that's what I'd like this to be. I'd like this to be lowercase long, but Java won't let me do that. So that's where there's maybe a little bit of inconsistency there. So I say do in background, so publish progress, and then publish progress comes over here. This is where that number goes to on progress update. You'll notice, though, that it's long ... You'll also notice here that it's void ... That's a little bit of an interesting syntax. So in Java, that ... means that this is it can take a variable number of arguments, basically. The function can take a variable number of arguments. So I could pass it 1 long, 2 longs, 3 longs, 10 longs. That's what the ... represents, is I can pass it as many of those as I want to. So the way that you can think about this when you're receiving it, when you're reading the data, this progress is not a long. It's actually an array of longs. Is everybody with me there? Progress is an array of longs, not a long. So if I'm passing just one number here, right, so that's going to be at index 0. So when I use progress in the code, you see I'm using progress bracket 0 because progress is an array. Is everybody with me there? Any questions? So, for instance, technically I could pass multiple numbers in here and publish progress. I'd say 1, 2, 1, 2, 3, and those would appear over here as indexes 0, 1, 2. But typically I'm just going to pass one thing through, and so that's where you'll usually just see a bracket 0 on the other side. Okay. So in the on progress update, I tell it to the adapter to notify dataset change. The reason that works is because I've already updated the actual list here. And so I updated the list, and so the adapter just needs to know that there's something new. I'm also telling the recycler view to go ahead and scroll down to the bottom of the list, which would be the number of numbers.size -1. That's the last index. And then I'm updating the progress bar. So you can kind of see the calculation I'm pushing off into here. So I'm just saying, hey, I'm going to just spit out I over here, and then I'll turn that number from 0 to 100. I do that calculation in on progress update. Questions? Okay. So like we mentioned previously, so on pre-execute happens before do in background. On post-execute is going to happen afterward. And you'll notice that, remember I set the result type to void, so I do have to return something, even though this is void. You know, typically when you say void, you'll know I usually don't have to return anything, right? But the problem is void is an object. It's not void, right? So this uppercase V is not the same as the lowercase v void, which means I do actually have to say return null rather than just letting the function end. Okay, with that uppercase void. So bear with me there. So effectively I'm passing null over to on post execute. So on post execute, that's the other place you have to check if it's canceled. Because commonly it might be canceled in somewhere in there and you didn't catch it in do in background. So it's pretty often that you may need to go into on post execute and check if it's canceled. Even if whether you have checks here or not, it's always going to call on post execute whether it was canceled or not. So you need to make sure to check if it's canceled. And so if it's not canceled, then we're going to go ahead and just update the UI with all the stuff we need to do. So notifying it that the adapter, the data's changed, the scrolling the recycler view to the bottom, setting the progress bar to 100%, and re-enabling the run button. Right. So this is where in on post execute is where you put all that cleanup code. Okay. Questions?
That's pretty standard right there. Mm-hmm. What you got, what's highlighted is just cleaning up. I mean, it may change a little bit, like our setting the progress. Why is set progress to 100 and not 0?
Well, this is when it's done, right? Zero would be here. 100 would be over here.
Okay, I get it.
Right. If I set it back to 0 here, right? So let's try it just with 100 and see what happens. So if I say, run, okay, so the progress bar ends up there. If I had set it back to 0 here, what would happen? Well, it would go over, and actually didn't take long enough. See, it went over and then immediately disappeared. See that? So I'm setting it to 100 so the user can see, hey, the process finished. Otherwise, this looks like something went wrong. Does that make sense? Does that answer your question?
That makes sense now.
So
I got it.
We just set it to 100% at the end. And that's just guaranteeing that it goes there. Part of the reason I need to do that, if I said, let's not set the progress here, and leave that one line out, let's say I go to 199,999. So this is not a nice multiple of 1,000. Well, here it goes. The first one goes in, then the progress never becomes 100%. You see that? So in terms of if you're having a progress bar, it's always a good thing to make sure that you set the progress bar to 100% when you're done, because otherwise it may get stuck here at 90% or 50% done. With me? So That's making sure you clean up after yourself, basically, or put things to the place where they need to be. Okay, so that's kind of a common way, and so basically what we're doing is we're taking just a long running calculation, a long loop, and pushing it to the background thread. That's what we're doing in this problem. Now let's look at the next one. And I'm going to go over to Simple Timer. And so Simple Timer, as the name says, it's kind of a simple program. What I'm trying to do is just get it every second to show the number of seconds since boot. That's all this does, right? So it shows every second. It's going to tell me how long it's been since boot. This is one of those things that really needs a little bit more multi-threading than the other one, right? This is not about this is really something that you can't just simply do a loop on the like we couldn't even have done it as a loop on the main thread. Does that make sense? So timers is another place where these come up. Anytime you need to update something, say every second, then I may need to put an async task in there. And so the way this operates, when we get to on start, we cancel the task if it's still running. We say, let's start a new task. And then the flip side of this is on stop. So on start is starting it, on stop is stopping it. So it's running as long as the activity is running. Okay. So that's hey, start and stop. Those things start coming back. And so here's my task, right? So this task is pretty simple. I've got a do in background, and I've got an on progress update. So let's look at what's happening in do in background. So I say while, as long as the task isn't canceled, we want to keep going. And in here I'm going to say let's sleep. So thread.sleep takes the current thread and puts it to sleep. It says just pause, don't do anything for the next second. Does that make sense? Right? So I put this thread to sleep for a second, and then I call publish progress. So effectively, this loop, right, is looping, and every second, it's calling publish progress. Everybody with me?
Yeah, so we'll just see it just hang for a second if we execute it.
What do you mean hang for a second?
Well, line 48, isn't that sleep the, it'll keep it from counting for a second, or did I misunderstand that?
You do misunderstand that.
Okay.
So it's gonna make a thread sleep, okay? But it's making the thread sleep that is the quote-unquote current thread, right? The thread that's running this thread sleep. So remember, I'm in do in background. Is do in background run on the UI thread or the background thread?
Oh, and who's buried in Grant's tomb?
It's on the background thread. Great, it's Grant. So I'm in the background thread, so I'm putting the background thread to sleep. I'm not putting the UI to sleep. Does that make sense? So it's not going to cause the UI to freeze because I'm not freezing the UI. I'm freezing the background thread.
Why are we doing that again? What's the point?
This. See how it's updating every second.
Mm-hmm.
Right? So I've got a counter. There's a lot of places where you might need to do some sort of countdown or count up. You might say, well, hey, maybe you're reserving tickets. And so your ticket reservation is maybe only good for 5 minutes, right? So you've got 5 minutes to check out, or the tickets are not yours, right? So I'm saying every second, let's update that counter so the user can see like how much time they have left, right? So, but here I'm saying time since boot. So basically I'm saying publish progress, and then every time here I go figure out, I can use the system clock, Android OS system clock.elapsed time. That tells me how much time it's been since the device was booted. And so here we can see it's been 15 hours, 59 minutes, and a few seconds. since the device was booted. And so I do some calculations and I spit that out, because remember, I can't update the UI directly here and do in background. I have to do the UI update back in the UI thread. Does that make sense? So a lot of times this async task can be used for things. Again, a lot of different things. So this is a timer with async task, rather than a like, here's a long calculation I need to do. And you'll notice what types have I put in for the async task. Void, void, void. That happens. Any questions on this example? Does that give you some ideas for what you could do with this so far?
Yeah, a little bit. It's just, there's so many methods and
right.
Just have to follow some examples.
Yeah. It's a very, very flexible tool. I hope that's, I hope that one of the things that you get out of this is to understand that this Asynctask class is a very, very flexible tool. There's a lot of different ways to set it up.
Yeah, with that, so we got our projects we're doing. I got the restaurant builder app, and I'm just trying to think, like, what would I use it for? I don't know if there's anything that would necessarily make my app collapse that's doing. I mean, it's good practice, I'm sure, but what would be an idea of what it could be done with the restaurant builder app?
Yeah, let's go through the third example, and then I'll show you what I've got for the worksheet. Because the blurb I want you to do for the lab for this is pretty simple, and it's make a separate app, actually. I've still got the worksheet kind of in progress, so I haven't finished it for the rest of the lessons for lesson 7 and 8, but the program I want you to make is pretty simple. But we'll look at that when we finish here. So next one, I'm going to hop over to simple fetch. And so what I do in this program is you can type in a URL and you can hit go, and there is the code for the page, right? So it just brings back the HTML. So I can say, let's go to example.com, and it'll bring down the HTML. As I kind of mentioned with other things, in the slides, anytime you need to get stuff from the internet, right? That can take time. On my network, right here it's almost instant, but it may or may not be instant depending on how much data you want to pull back or how fast your connection is. Okay. So, let's look at quickly, where's the interesting code that happens with this? Well, so in main activity, I've set up a lot of these things the same way as even just the first example. And so, in here we parse the URL, check if it's okay. If I get an invalid URL, then I'm going to just say, well, actually I need to just erase there. So if I have an invalid URL, it's just going to say, please enter a valid URL. So it only starts the task if we have a valid URL to begin with. So assuming we have a valid URL, we go down here, constructor takes a URL object. When it starts executing on pre-execute, I'm going to say, let's set the text to downloading ... Go button, we're going to disable it. So that's just, getting some things set up before it starts. That in this case is almost gone instantly because the network's fast enough. And you can kind of see the same sort of thing on the other side. When we get done, we set the text and we re-enable the go button. So internally to here, right, is some logic that is pulling down the HTML basically for that URL and putting it into a string builder, which in the end we show. Okay, so we can use this to pull down resources from the internet.
Just out of curiosity,
Yep.
You got a triple nested try there, a double.
Yes, I do.
Where, did you come up with that, or?
Yeah, and this is actually the right way to do this. So the outer try, you see I'm saying try and catch. So that's if anything goes wrong, that's the outer try. So the outer try, I'm saying if something goes wrong, then let's log the exception, and I'll show it here in the result. Basically, I'll update the result there. So that's that. Okay, the inner tries are kind of some interesting tries. You see this try? You see how there's parentheses between the try and the curly brace?
Yeah.
So that is a special kind of try. We call that a try with using. It's a newer language feature in Java. Okay, and it's a shorthand. So what it does is it automatically, if anything goes wrong, if there's an exception, it will automatically close that resource. Otherwise, I would have to go through all the code and make sure I clean up after myself. But it takes care of the cleanup for me. So, because what I'm doing is I say, well, let's take the connection, get an input stream that opens up the input stream is where we're going to read the data as basically a byte array, stream of bytes. But I have to make sure that I close that if anything goes wrong, because otherwise it will stay open. It doesn't get garbage collected like you would like it to be. So if you don't close it, you will eventually run out of memory or resources, and your application will crash. So I need to make sure that it gets closed. Well, that try with resources takes care of that. So if anything goes wrong, it's going to close the input stream. Same thing with the reader, because I need to now create a reader around that input stream, and that reader basically lets me read it as text instead of reading it as bytes. So once I've got it in my buffered reader, then I can actually read it line by line. So yes, there's 3 tries. And that is a very common pattern. If I was reading a file from the disk, I would need, like a text file from the disk, I would need to do the exact same thing here, where I would need potentially 3 tries. Sometimes more. 3 is kind of your base minimum with Java. Any questions? You've got these example programs. Any questions right now on that material?
Yeah, it just looks like all the work's in the doing background. All the other stuff's kind of just repetitive or mostly predictable.
Yeah. Worth just a reminder, on pre-execute and on post-execute, those are optional. But yeah, you usually end up having something you need to do in both of those methods. Okay, so let me pull up the lab assignment. So your lab assignment for today and tomorrow is pretty easy. I'm going to go ahead and copy it into Discord here, and I will put this up on Inside Ranken as well. But what I want you to do for this material is you're going to create an application, just basically showing a simple progress bar. And so you're going to start an async task when the user clicks a button. Let the do in background basically send progress for every second. And then after 5 seconds, you're just going to tell the user that the process is done. Cool.
So this is just like a simple one-page.
Simple one screen.
Like we did this semester, just some math.
Yep. Just to get some practice with it. Because the next kind of step where this fits in is to kind of like, you can think of this as like, hey, I want to put in an order screen. And so it's going to go, maybe I go place an order with the Droid Cafe. It needs to go send what's in my cart up to the service, and then the service the server needs to check that's okay, and then come back, right? So this is kind of getting you prepared for working with progress bars. Troy, were you trying to say something?
I don't think so.
Okay.
Mr. Smith.
Yep.
That isn't uploaded yet to the inside Ranken.
Yeah, I'll put that here as soon as we get off the call.
Okay.
You're going to mention how it might be used in some of our applications.
So is it, as far as this fits in, right? So if you're thinking about your menu application, right? To kind of give you the, to give everybody else here the lowdown on that. So do you want to actually? I'll let you do that, Paul. Give the other students a lowdown of what you're building in a few sentences.
Okay, it's a simple app meant for a restaurant owner or manager to create a menu where there's a image of the food, a price, the title, and a description. And there's a home screen that's got the menu that's been built out. And then you can either add a menu item or edit something that's there. And then, of course, there's deleting as well. So there's 3 activities altogether: the main activity, add, and edit.
Right. So all 3 of those are going to need a different async task in the long run, right? So, or relatively short run. So if you think about the first activity, the list of menu items, right? Well, that is probably going to need to come from a server somewhere, or a website, a database somewhere, so that you can have a shared menu, right, that appears both for the manager as well as your customers, right? So loading up that menu requires a network access. So you'd have an async task to go get the list of menu items. And then anytime you need to modify that list, that's also a network call. So you would also have an async task to add a menu item. You'd have an async task to delete a menu item. You'd have an async task to edit a menu item. Does that make sense? So
yeah, just database stuff.
Yeah, all of your CRUD operations are going to be a different async task.
Okay. Yeah, obviously we'll have to get into databasing before we can do that, right?
Right. So that's why I've asked you to just do something as a separate application, because a lot of you may not be in a place where it necessarily fits well with what you've done so far. Cool.
Yeah, our projects are kind of on hiatus until we learn this stuff then, maybe for like a couple of weeks.
Yeah. So some of these next few projects will probably be just little small one-off things, and then we'll come back to, as we start putting the pieces together, we'll come back to your final project.